All right, guys, we are going to do dividing. There we go. Dividing radicals next. So you've simplified radicals, you've multiplied radicals. Now, the next thing would be to divide. We're going to start out the same way. Listen out the first 10 perfect squares, and you know how I am. I'm going to do the first 15. So I'm going to do 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and then down the side I'll do the next 5. So 121, 144, 169, 196, and 225. So I just like having all of those listed out. It just helps simplify things a little bit. So you figured out how to multiply radicals, right? And we're actually going to use that a little bit to divide. So it's good that you learned that first. So it says here for steps, if I have, before I even look at the steps, if I have this as my original problem, this is example number 1, radical 12 over radical 10. I can't take the square root of 10 and get a whole number, right? So that makes that an irrational number. The denominator is irrational. We can't have that. We cannot have that. So the very first step says to rationalize the denominator. What they mean is turn that into a rational number, right? So how do we do that? It says by multiplying the top and the bottom of the fraction by the denominator. Now think about what that's really doing, right? If I multiply a fraction by the same thing on the top and on the bottom, I haven't changed the value of it at all, right? So by multiplying both the top and the bottom by radical 10, even though it changes what's on the bottom, I haven't changed the value of the fraction. The fraction is still worth the same amount. It's just now I got rid of having an irrational number on the bottom, because look what happens here. They show you this in the example. Radical 10 times radical 10, well, as you guys learned earlier, we can rewrite that underneath the same radical sign. 10 times 10 is 100, so really that's radical 100. Well, I know the square root of 100. It's 10, right? So now I have a rational number in my denominator. There's no square root symbol at all. It has a perfect square in the bottom now. So I can take the square root of that and get rid of the radical altogether. It's just 10 in the denominator spot. Now, what's on the top is radical 120, and we're going to do just like what we did for our first lesson of simplifying radicals. We've got to simplify radical 120 using those first 15 perfect squares to see what number goes into it that I can use to simplify this. Okay. Now, the confusing part is once you get your answer, once you've simplified and you pull out the number from the underneath the radical sign, you got to look at the two numbers. I shouldn't have circled the whole thing. You got to look at the two numbers that aren't under the radical signs, right? 2 and 10 are not under the radical sign. So if I had just the fraction 2 over 10, you guys would all know, oh yeah, that simplifies to 1/5, right? So that's how they get this answer from what they had originally. They said, oh, well, I'll just simplify that to 1/5. Do we have to put the 1 in front of the radical 30 to show that we're multiplying it by 1? No, you don't ever have to show that you're multiplying by 1. So it just stays radical 30 now on top, and the denominator is a 5. So simplifying radicals and simplifying fractions, it's two of your favorite things. And that's what we're going to do here. I'll do some of these examples. So, I didn't say all the steps. Let me finish saying all the steps. Rationalize the denominator by multiplying the top and the bottom by the denominator. Find the largest perfect square that is a factor of the radical, so the top. Simplify the radical, and then simplify the fraction. So for example number 2, we've got radical 75 over radical 27. Radical 27 is the denominator. That's irrational. We can't have that. So I'm going to start by multiplying both the top and the bottom by radical 27. Okay. Well, that means I can do radical 27 times radical 27 on the bottom here. So on the top, it's going to be radical 75 times radical 27, and I can put those both underneath the same radical sign, right? And on the bottom, I'm going to have radical 27 times radical 27, and I can put those under the same radical sign. Well, 27 times 27 is 27 squared. And when I'm taking the square root of something that's being squared, remember they cancel each other out. Okay, so I've got just 27 on the bottom now. No radical. But I got to do the top. And I'm going to use my calculator here. 75 times 27 is 2,025. So I've got radical 2,025 on top and just 27 on the bottom. So I've got to simplify this. Okay, I've got to simplify the radical that's on the top. So I got to think, okay, what perfect square goes into 2,025? That's a big number, right? So I'm going to focus in. I'm going to do something to make it a little bit easier. I'm going to focus in on the two radicals that we just multiplied together. We multiplied together 75 and 27. What perfect square goes into 75? That's pretty easy to think of. 25. 25. What radical or what perfect square goes into 27? Out of all those perfect squares that we listed out, 9 goes into 27. So I'm going to take a shortcut here. I'm going to do 25 times 9, just because 9 goes into 27, 25 goes into 75. So those numbers should also multiply together to go into 2,025, right? And when I do 25 times 9, it gets me 225, which is actually our largest perfect square, right? The largest perfect square that we listed out, boom, right there, that guy, 225. So I'm going to break this, I'm going to simplify this top fraction by multiplying 225 by radical what? 225 times what equals 2,025? Well, I got to do 2,025 divided by 225, and that gets me 9. So I've got now radical 225 times radical 9 all over 27. Well, we know the square root of 225 is 15. It's our 15th perfect square. But look, the second number under the radical is also a perfect square. 9 is a perfect square. So I get to pull out two numbers. So really, it's just 15 times 9 on top. And then 27 still on the bottom. So then just do 15 times 9. Well, we already know that. It's 225 over 27. You can leave your answer as an improper fraction. If you wanted to use your calculator to turn it into a mixed number, you could do that as well. In fact, let me do that real quick. 225 over 27. That does equal 8 1/3 when you simplify it. Okay, so this one is kind of unique because it simplified all the way. It got rid of all the radicals. We rationalized the denominator to get rid of the radical on the bottom, but then somehow, miraculously, it got rid of the radicals on the top too. That's not going to happen very often, okay? For example, let's look at example number 3. So for example number 3, I see this 5 radical 7 over radical 3. I don't want a radical in my denominator. That's irrational, right? That's irrational, the square root of 3. So I've got to get rid of it. I'm going to multiply both the top and the bottom by radical 3. So I've got 5 radical 7 times radical 3 on top. And then I have radical 3 times 3 on the bottom. I forgot. Let's combine those on top. Since they're both radicals, I can include them underneath the same radical sign. So I've got this. Go ahead and, 3 times 3 is 9. Square root of 9 is 3. That basically it's just 3 on the bottom, and then it's 21 on top. So I've got 5 radical 21 on top, and then just 3 times 3. Oops. 3 times 3 is 9. But yeah, we're taking the square root of that. It's just a 3 on the bottom. So then go ahead and look. Can you simplify the numerator? Can you simplify that radical 21? Check all the perfect squares. Half of 21 is 10, so I'm going to check the first 10 perfect squares that are lower than 10. It's just 9, 4, and 1. 9 doesn't go into 21. 4 doesn't go into 21. I mean, 1 does, but that doesn't help us. So I'm actually done. with this one. And you can see I've got this answer that still has the radical in it, and that's how most of these are going to work out for us. Okay. For example, number 4, same thing. Radical 48 on the bottom. Can't have irregular. Can't have an irrational number on the denominator, so I'm going to multiply both the top and the bottom by radical 48. When I do that, I get the 2's out in front, so it stays out in front, just like we learned before, right? 2 times radical 56 times 48 on top. And then 3 is out in front, so it stays out in front. Radical 48 times 48. Well, you guys know what's going to happen. 48 times 48, and then that's 48 squared, and then I'm taking the square root of that. Yeah, that's just going to be a 48. It gets to come out of the radical. Okay. 3 times 48 is, what is that, 144? We'll get to that in a minute. Let's do the top. 56 times 48. If I do that, I need my calculator for that. It is 2,688. So let's go ahead and simplify the denominator first. 3 times 48. Let me double check. I think it's 144. And it is. So I've got 144 on the bottom, and then 2 radical 2,688 on top. All right, so we got to go through, our perfect squares again and just start testing them. Let's start with the highest one that we have. The highest one that we have written down is 225. Well, we know 225 is not going to end in an 8, right? If I multiply by any number, it's not going to end in an 8. So 225 doesn't go into it. Let's check the next one, 196. If I divide 2,688 by 196, that gets me a decimal, so that doesn't work. If I do 2,688 divided by 169, does that work? Get another decimal for that one as well. So check the next one, 144. So 2,688 divided by 144. Get another decimal. Let's try 121. So 2,688 divided by 121 gets me another decimal. 100 is our next perfect square. Do I even have to test that? We know 100 doesn't go into something that ends in an 8, right, without a decimal being there. So let's check the next one, 81. 2,688 divided by 81. Check that. It gets me a decimal. Let's check the next one, 64. So 2,688 divided by 64. And I finally get a whole number. So I know that radical 64 goes into radical 2,688. But how many times? Well, when you type that into your calculator, 2,688 divided by 64, it gets us 42. All right, so I'm ready to simplify that. The square root of 64 is 8. So that turns into an 8 when I take the square root of 64. So I've got 2 times 8 radical 42 all over 144. Okay. 2 times 8, there's the bell. 2 times 8 is 16. So I'll simplify that first. So I've got 16 radical 42 over 144. And then just look to see, for sure we know that we can divide both those by 2. They're both even, right? 16 and 144, because we got to simplify the fraction. But is there any other thing? I'll use my calculator to check that. If I do 16 over 144, it simplifies to 1/9. So I don't have to write the 1 on top. It's just radical 42 over 9. And that's it. Okay? So your assignment is just working through that. They do take a while, right? I'll do the first one with you just to to help you out, cut down on your assignment a little bit. So for number 1, the first thing I'm going to do is multiply both the top and the bottom by that radical. Oh, almost forgot. Well, let's take a second and write out the first 15 perfect squares. So I've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. All right. So those will help, knowing what those are. Go ahead and multiply those, and we get radical of 6 times 15 on top and radical of 15 times 15 on the bottom. Well, we know that just means 15 on the bottom, right? Because 15 times 15 is 15 squared. Take the square root of that. They cancel each other out. It's just 15. 6 times 15 is 90. So I've got radical 90 on top. And then it's time to see which perfect squares go into 90. It ends in a 0, so I know it's divisible by 10, and I see that 9 is what I would multiply it by. So that's what I'm going to start with. Radical 9 is the highest perfect square that goes into that, times radical 10. Well, I can do the square root of 9. The square root of 9 is 3. So now, instead of radical 90, I have 3 times radical 10 on top and just 15 on the bottom. Radical 10 can't be simplified any further, but 3 over 15 can be simplified further, right? 3 goes into both of those. 3 goes into itself once. I don't have to write the 1. I just write radical 10, and then 3 goes into 15 5 times. So that's my answer. All right, guys, good luck on the rest of this. If you need any help, make sure you ask your teacher.